Hello, adaptive coders. My name is Shawn, and I will be your instructor today. You're watching Lesson 8 of the Python for Beginners series on the Coding with Shawn channel. In this lesson, we will learn about tuples, the try and except statements. We're going to proceed learning about loops, and we're going to learn about variable scopes, also known as local and global variables. We're going to learn how to import modules, and stick to the end for the bonus of learning how to create your very own module. Now that that's over with, let's begin. So let's talk about tuples. A tuple is created by placing all of the items or elements that you need to put inside parentheses and separating them with commas. The parentheses are optional, though it is a good idea to use them. A tuple can have any number of items, and they may be of different types, such as one might be an integer, one might be a float, a list, a string, etc., etc. The only major difference between a tuple and a list is that a tuple does not have the ability to be modified once you have put the initial values. However, with this comes the ability to be processed by Python or Python interpreter faster. So let's actually write some tuples. There are 4 different types of tuples. They are empty tuples, tuples with integers, tuples with mixed data types, and nested tuples. So let's make an empty tuple. Make a variable, let's just call it tuple, and just assign it a blank pair of parentheses. Then make a print statement and tell Python interpreter to print tuple. Let's run this. When we do so, we just get empty parentheses, which is exactly what we bargained for. Next, we have tuples with integers. So go ahead and edit inside your parentheses and just add 1, 2, 3. Once you've done that, run the program. And again, exactly what we asked for, 1, 2, and 3. Now, we have another type of tuple, which is, of course, tuples with mixed data types. And for this, let's put 3, let's just say apple, and the float 4.7. Let's run this, and that's exactly what we get, 3, apple, and 4.7. Our final type of tuple is a nested tuple, and for this, let's begin with a string. And that string, why don't we just call it apple? Then we are going to put inside brackets 1, 2, and 3. Then, inside parentheses, let's put 4, 5, and 6. Now let's run this. And what do we get? Apple, 1, 2, 3, and 4, 5, 6. Exactly the way we told Python interpreter to do it. Now, these are the basics of creating a tuple, but this is not everything. We can also create a tuple without parentheses. This is known as tuple packing. Let's keep our variable tuple and assign it without parentheses 3, 4.5, apple. Then let's keep our print statement and inside it put our variable tuple. If we run this, we get 3, 4.5, and apple. Awesome. So that is really what a packed tuple is, though it is possible to unpack a tuple. For this, let's make 3 variable type things, a, b, c. And let's assign this tuple, which is our variable, of course. Then put print a, print b, and print c. If we run this, we will get each individual asset of the tuple. And this can be incredibly useful in some circumstances. When you are in a real need of Python's quick processing, then this can be good because a tuple is already fast, but if you really need extra speed, a packed tuple can really help because you still can unpack a tuple if it is actually necessary. So while I wouldn't recommend using a packed tuple, it can really be useful in certain scenarios. So our final thing to do with tuples is creating a tuple with only one element. So this can be a little bit tricky. Having one element in parentheses is simply not enough. We'll need a trailing comma to indicate that it is in fact a tuple. So let's create a variable, again, we'll just call it tuple, and assign it the string hello, inside quotes of course. Hello. Okay, then just put print type, and then another pair of parentheses, and a variable tuple. If we run this, Python will tell us that this is a string, not a tuple, because this has no comma. So Python just assumes that you're trying to print a string. So if we wanted Python to actually accept this as a tuple, we would have to add a comma. And if we put this inside of hello and we ran this, it would still give us string, because this is not actually a comma which represents a tuple. This is simply a comma inside a string. To do this, we would actually need to put our comma outside of the quotes. And if we run it this time, it will give us class tuple, because this is actually a tuple due to the fact that it does indeed have a comma. Now, to show that these tuples are actually in fact going to work the same way, even if the parentheses are not there, we can take out our parentheses, and if we run this program, we will still get the class tuple, because again, tuples do not require parentheses, though it is a very, very, very good idea to use them, because there are plenty of scenarios where not using a tuple can cause your program to either malfunction or completely refuse to work the way it is supposed to. So again, I'll say that one more time because of how important it is. When you're writing a tuple, parentheses are not necessary, but they are a good idea to add if you can do that without it being an issue. So that is really all we need to know about the tuple, and we will get more detailed into what we can do with a tuple as we proceed into object-oriented Python in this series, but as for now, that's all we're going to do, and next up, we're going to learn about the try and except statement. Let's talk about our try and except statement. So the try and except statement is what we know as a control statement, because it controls the program's response to something when something happens. So let's put this into code so it'll be easier to understand for you. So we would have try as one of our keywords, and we would tell our Python interpreter to do something here. Then we would have our except part, or our except keyword, and then here we would tell Python interpreter to do something else when an error occurs. Okay, so let's actually try running a program. So we're going to have inside our try keyword, answer equals 12 over 0. And then we're going to have our except, and we're going to do an error occurred. So we're going to do print print an error occurred. Now before we do proceed, we do of course want to add a print statement after this. Print answer. Okay, so let's run this. And when we do, we're going to get an error occurred. This is because when the program tried to execute the statement answer equals 12 over 0 inside of the try block or the try section, an error occurs since you cannot divide a number by 0. The remaining of the try block is ignored and the statement in the except block is executed instead. Now this statement can actually be very, very useful because it's a lot better to get an error occurred than it is to say print 12 over 0, and then if we run this, we're just going to get random things from Python. And of course, if this was on a website, a user would probably not understand what traceback, most recent call, last file, blah blah blah. It would be very, very confusing for the user, and I don't think they would be very happy. So this is very, very useful and very, very commonly used in websites that use Python, because it can be very, very useful as I've just demonstrated. So let's say that we want to display more specific error messages to users. So depending on the error, you have to specify the error type after the except keyword. So let's try this. Go ahead and put the try keyword followed by a colon, and then let's make a variable called user input 1, and this is going to be integer input. Then inside that we're going to put please enter a number, and then a colon. After that, we're going to put user input 2 equals integer, or rather int as our keyword, and then input, and then inside quotes, of course, we're going to put please enter another number. Okay, and then of course that should be preceded with a colon, and then we're going to have another variable called answer, and we're going to make that user input 1 divided by user input 2. Okay, then we're going to add a print statement, and we're going to put print inside quotes the answer is a quote, and then a comma, and then our variable answer. After this, we're going to put my file equals open, and then a pair of parentheses, and inside those parentheses, missing text, missing.txt, and then after, we're going to go ahead and skip to after the quote, we're going to put a comma, and then we're going to put inside single quotes just the letter R. After this, we're going to actually press the delete or the backspace character and go to the actual side of the line, because if we do go ahead and click enter from here, we're going to be stuck right here. So just go ahead and click the delete or backspace button from here, and then you're going to put an except statement. So except value error, colon, and then print error, colon, cannot divide by, or excuse me, this is the wrong one, my bad. We're going to put you did not enter a number. Then we're going to put another except statement. This time it's going to be a 0 division error. Do make sure that you have spelled it correctly, because if you do not, this can be a very big problem. If you have spelled it incorrectly and you're using PyCharm, you will notice that the color will be different and it will not be purple like it is right now. We're going to, after this 0 division error, we're going to put a colon, and we're going to put print inside quotes error, colon, cannot divide by 0. Cannot divide by 0. Okay, next we're going to have one more except statement, or rather except keyword inside the try except statement. And, or excuse me, we do not need that colon. And we're going to put, this time, exception as E. Exception as E. And then a colon. And then we're going to put print unknown error, and then a colon, and then a quote, then a comma, then E. And you can go ahead and take this last code out. So let us run this, and if we do, we're going to get a invalid syntax error. And the reason for this is because we have forgotten our number 1 quote, which is supposed to be at the beginning of our unknown error section. So if we go ahead and put this here, this will complete our string from here to here. And let's go ahead and run this again. And we're going to get please enter a number. So if we don't enter a number, let's say we enter A, we're going to get error, you did not enter a number. Run this program again. Please enter a number. Let's say we put 5 this time. Please enter another number. Let's put 2. The answer is 2.5. Unknown error, error node 2, no such file or directory, missing.txt. And okay, so we're going to go ahead and move on. So we can also get other things such as a value error block if we change our different mistakes, such as, okay, that is really difficult to really say in words. So let's do this in more realistic things. Let's put 12 and then 0. We're going to get an error because we cannot divide by 0. Next, let's put something like 12 and M. We're still going to get error, you did not enter a number. And this is useful because all we have to do was put it once, and it's useful in 1, 2, even 3 different lines. And okay, so those are really the major things that we're going to have with the errors. And this is very cool. So if you want to go ahead and play around with what you can do with this, then go ahead, because there are multiple things you can change or add. And well, this is very nice. There are other errors actually that we can add. They're including the IO error, which is raised when an IO operation, such as the built-in open function, fails for an IO related reason. For example, the file was not found, and IO, if you are wondering, means input-output. We can have an import error, which is raised when an import statement fails to find the module definition. We could have an index error, which is raised when a sequence, such as a string, a list, or a tuple index, is out of range. We can have a key error, which is raised when a dictionary key is not found. We can have a name error, which is raised when a local or global name is not found. And when you do hear local and global, you're not going to understand it quite yet, but we're going to learn it by the end of this lesson, what a local or global variable is, so don't worry. We can have and the final thing, we can have a type error, which is raised when an operation or function is applied to an object of inappropriate type, such as instead of putting a string, they put a tuple, etc., etc., etc. So there are a lot more error types actually. I just covered the most important ones. And for this, you can go ahead and refer to the Python documentations at www.docs.python.org/3/library/exceptions.html. Now, of course, I don't expect you to remember that, so I have linked that documentation in the description if you do want to check that out. Python also comes with predefined error messages for each of the different types of errors. If you wanted to display the message, you could use the as keyword after the error type. So for instance, to display the default value error message, you could put something around the borders of except value error as E. And then let's just say that we could put print E. So of course, we're not actually going to print this because we have not added a try before this. But that is really there are a lot of things we can do. Again, you can play around with this. You can read the documentation a little if you want. It can really help because the things you can do in Python are nearly impossible to explain in any lesson. So again, if you want to refer to the documentation, that could be a good idea. And yeah, well, there are some other things you can do. E is the variable name. For example, in this situation, E is the variable name assigned to the error. So you can give it some other names, but it is common practice to use E. The last except statement in our program, which is if you have not already deleted it, it was except exception as E, and then we had print unknown error. Unknown error. And then a quote, a comma, and E. This is what we had, and it is an example of using the predefined error message. It serves as a final attempt to catch any unanticipated errors, or errors that we really just didn't know how to fix, or something that where the user writes something that we didn't already specify what to do. So for example, if we put a special character like the star character, which would be this one, or the parentheses or something like that, where we didn't actually know what we were going to do, it could give us the error where we decided to tell it to give us, I believe it was our, it was you did not enter a number, but there are a lot of special scenarios which a human mind couldn't even comprehend. So this is very, very useful of using Python's inbuilt system to use in your very own programs, in your very own lines, in your very own code. Next up, we're going to learn about the variable scope. Wonderful. So now, let's move on to our variable scope. So, an important concept to understand when you're defining any function is the concept of a variable scope. Variables defined inside a function are treated differently from variables defined outside. There are two main differences. Firstly, a variable declared inside a function is accessible only within the function. These are known as local variables. Any variable declared outside a function is known as a global variable and is accessible anywhere in the program. Let's put this into code. So go ahead and make a variable called message1, this time not abbreviated, and assign it global variable as a string, and then go ahead and inside parentheses put shares name with local variable. Wonderful. Now go ahead and make a function using def, D-E-F, and put my function this time. We're going to call it something different just so you don't get confused. And put a parenthesis, or rather a pair of parentheses, and make sure to leave them empty. And then a colon. And then inside it put another variable, and believe it or not, even though these variables are named the same thing, they are different things, because this one here is a global variable since it's not inside the function, and this one here is a local variable, and it can only be called inside this function, as we will see in just a minute. So call this other message one in a string. Of course, we're going to assign it the string local variable shares name with global variable. Okay. Then we're going to, again, still inside the function, we're going to put print, and inside that statement we're going to have quotes \n inside the function. Then we're going to add another print statement, add another pair of quotes, another \n, and we're going to call this one, or excuse me, we're not actually going to add this \1 or the quotes. I got a little confused there, I apologize. We're going to actually put our variable message1. Okay, now we're going to go out of the function, and we're going to call our function, which is my function, of course, my function, and add the add the parentheses too. And this time we don't need a colon since we're not really specifying anything. We're going to put another print statement, quotes \n outside the function. Then we're going to go ahead and click enter to go to the next line and print message1. Let's run our program now, and once we do, we'll see that we get inside the function, and which is the local variable, which shares a name with global variable, which is this one right here, because this is message1 that has that exact string. And we have outside the function global variable, which shares a name with local variable, which is going to be this one right here. Now you might ask, why are they different? Well, as I said earlier, a local variable is only if it is named the same as a global variable. A local variable is only accessible if printed inside of the function, and a global variable would only be accessible outside that function. And you do have to be very careful with this when you're programming, because you might accidentally call that variable inside of a function or outside of a function and mean the other one, which is inside or outside the function. And this can cause a disaster and completely ruin your program. So Be very careful when you are doing this, but it is still useful in some scenarios, as almost everything is inside of Python. So that is pretty much everything you need to know about variable scopes, including local and global variables. So without any more time wasting, let us move on to our module section, including importing modules, and of course our bonus, creating our very own module. Let's go. Modules. Modules are some of the most useful things in all of Python because they allow you to harness the full power of Python and all of Python's inbuilt functions. The reason they're not inbuilt into Python itself is because Python does not want to irritate you or overwhelm you with all the functions that Python has. So for this, Python has built modules, and modules contain more specific things related to the thing you are trying to get. So there are a lot of ways to import modules. The first way is to import the entire module by writing import and then module name, or whatever your module name is. So let's say we wanted to import the module, or excuse me, let's say we wanted to import the random module. We would put import and then random. It's that simple. Okay, so let's say that we wanted to use the rand range function inside of the random module. For this, we would put random.randrange, and then inside parentheses, we would put 1, comma, let's just say 10. This is not a requirement for you to put 1 through 10, but let's just say we wanted to do that. Well, for once, when you do write a lot of these, you may find it a little troublesome to write random or whatever your module name is over and over and over again. And there is a way to fix this, or really help you with this. And that way is you can import the module by writing using the as keyword to import a module as something else. So let's say we wanted to import random as r. Then we could, instead of putting random, we could instead put r.randrange. And it would use this, and it would be the same thing. It would still work exactly the way as expected. There is another way to import modules, and that is to import specific functions from the module by writing from, and then in our scenario we're using the random module, but you would put whatever your module is, and then we would put import, and then whatever you're trying to import. So let's say we were trying to import rand range, we would just put rand range, and then parentheses. So then we could just write, we don't even have to put r dot, we don't have to put a dot at all, we just put rand range, and then 1 to 10, and it would do exactly the same thing. Because now we're not really importing the whole module at all, we're just importing that one specific function. So that is really just the basics of this importing thing, and it's really very useful. And if you do want to see all the things you can import, that is available on Python's official website at python.org. So if you do want to use some of the other modules, play around with it, I would recommend that. It is on python.org if you are looking for it. But other than that, now we're going to create our own module, the bonus for getting this far. Let's create our very own module. Creating a module can actually be very, very useful, mainly for the instance that you want to use specific functions in a future project. Now, with this, creating a module is also very, very simple. And, well, let me go ahead and teach you, because it is actually very simple, it will not be difficult, and it can be useful, as I said just a moment ago. So we're going to go ahead and write some code, and you don't really have to know what this means. Just go ahead and copy this down so that that way you can actually do what I do, and I can show you this because this is a very, very simple module, nothing complex. Just put def, then greeting, then in parentheses put name, and then put a colon, and then put print, and then inside quotes, hello, then a comma, and then plus name. So that's really all you have to do for the entire module, believe it or not, because this is a very simple module. Then go ahead and wherever it is, click Save As. Okay, make sure that it is in the Hello World directory. If it is not in the Hello World directory, this will not work, I promise you. So go ahead and click this and click Hello World somehow. It'll be there, and if it's not, click here, and you have to find it in your actual computer. So you'd click this, and then you'd have to find it in your computer. So you'd go into Python projects, and then you'd click Hello World, and you'd actually just click Hello World and click Open there. And that will bring you to the Hello World directory. And then click Refactor. And okay, it gives me this because we already have a firstlines.py. So to avoid this, we're going to actually have to rename it to something else. So you can really name it to whatever you want, but for me, I'm going to go ahead and name it. I'm going to name mine my module. You can name yours first module, this module, that module, whatever you really want. So we're going to refactor it, and then go back to our firstlines.py file, and we're actually going to do this pretty much exactly the way we imported the random module. To do this, we're literally just going to type import and then whatever your module name is. For my case, it's my module. And then the only function we put in there is the mymodule.greeting. So we're going to put mymodule.greeting. Then my name is Shawn, but you can put whatever your name is. We run this, and I get hello, Shawn. Now this is probably very cool. Go share this to your friends, your family, whoever you want to, because this is super cool, and I think they'll actually kind of like this, particularly if they are someone who is an aspiring coder. So yes, that is really how you create a module. Of course, this is a very, very simple module, nothing complex here. But this is really what people do to create modules. Even if it's a million-line module, it all starts with this one little tiny function inside of the module. So with this, we do conclude today's lesson. Very, very big congratulations for making it this far and learning how to create your own module. Of course, every time you code, there's a million ways you can mess up, and if you do have any problems, please do write a comment in the comment box below, because I'm always available to help you guys if you have any problems, issues, feedback, or suggestions, or questions, of course. So feel free to write down in the comment box section if you do have any questions, suggestions, feedback, or anything that I need to help you with. But yes, thank you so much for making it this far. Thank you for watching this lesson. If you do like it, please do like it. Like this video, and please do subscribe so this content can keep coming. Again, big thank you to all viewers and subscribers, and I really hope to see you in my next lesson or one of my other videos.